The SV08 was the last Sovol printer stock with slow inductive probing. Not anymore. The official Eddy upgrade kit is finally here, and I can report the hardware is great. And the setup is surprisingly fast and very easy. But it has one fatal flaw straight out of the box, a flaw that can literally drill a hole in your build plate. In this video I will guide you through the installation, but more importantly I will show you the essential safety fixes that Sovol missed, including a custom bed saver mod that protects your printer from homing errors and the problem with the Eddy sensor. Many of these Klipper tricks apply to any printer, but this Eddy probe upgrade is the most exciting addition to our SV08 in a while. If you're new here, this is gerGO, and welcome to our channel, gerGO Print 3D. Well, if you're not new here, I'm still gerGO. My little nephew Levi and I are documenting our adventures with our 3D printers, lasers, and even CNC machines here, often making mistakes so you don't have to. And just like our extensive back catalog of videos, this one has curated, translation-ready subtitles, detailed chapter markers, and voiceovers in more than 20 languages. It always felt a bit ironic how the tiny Sovol Zero used a lightning-fast Eddy scanner on its small build surface, while our big SV08 meticulously pegged each probing point 2 or 3 times just to get a somewhat accurate readout. And that was after warming up its inductive sensor for minutes. You can check out our earlier, very popular videos where I tested and improved that original probe. Yet, bringing the Eddy sensor from the Zero and Max variants of the regular SV08 was one of the top requests from the community, and Sovol finally delivered. Some of you might have already added your own Eddy NG upgrade, which might even be superior in speed or accuracy, but none are as easy and elegant to add as this official kit. No need to fundamentally change the firmware, no extra wires, no need to source parts from multiple places. It's a plug-and-play solution that for me worked right on the first attempt. Well, the first attempt, yes, but not the second. Don't worry though, that kink is ironed out with a simple software mod, and we'll get to that soon enough. But before we get into the installation, let's give a warm shout out to PCBWay, who are sponsoring this video as well. Honestly, this is the best time to utilize their services because their Christmas big sale is running until the end of the month. If you want your projects to stand out, you can now get premium solder mask colors like purple, matte black, and pink as a free upgrade. On top of that, they are offering a coupon bundle worth a whopping $435 and saving you up to 50% on orders. And for us makers, even their 3D printing materials and CNC services have major discounts right now. It's the perfect time to try them out. Use our link in the description to grab these deals before the year ends. And now to the upgrade at hand. Let's see what that 43 bucks gets us. We actually unboxed this during our recent live stream celebrating Thanksgiving and hitting 10,000 subscribers. Just incredible. It was a 2-hour whirlwind of 3D printing, giveaways, and unboxing a massive haul, a gift box from Sovol, a bunch of Hotto tools, and even this incredible 30 psi airbrush kit we found on AliExpress. We managed to snag the most complete variant for well under $80, including shipping. I put the link in the description because this is a steal, and you can be sure to see us making a mess with this very soon. Sorry, I got a bit sidetracked, but of course, amidst that chaos, Levi tore into this Eddy sensor kit as well. Honestly, I'm just happy that by the end we somehow managed to separate the Eddy components from the airbrush parts without losing a single screw. Here they are, laid out on my desk, matching the user guide perfectly. But stop! Before grabbing that new Hotto screwdriver, let's first sit at the computer. Rewriting firmware will wipe your config files. So go into mainsail, highlight everything in the config folder, and download them. Trust me, You'll be glad you did. First, huge praise for the user guide. It's colorful, detailed, and logical. A+ Sovol. Following, page 7, home, turn off and unplug the printer. Remove the old brush and load cell combo. That never worked well anyway. Tape up the unused wire. They even included a tape in the package. The new unit fits right in. It's a silicone brush for wiping and a metal mesh for scrubbing and cooling. Much better. Install it using the same screws, but keep in mind we will be revisiting this block later for our Bat Saver mod. Next, the main event. The new probe needs the included replacement tool head cover, which means moving the part cooling fan. It's not rocket science, but the guide breaks it down to 6 easy steps. Remove the old inductive probe, connect the Eddy probe wires before mounting it in the same spot using the original screw. Rut the cables neatly. The probe sits very close to the nozzle, great for accuracy, but terrible for heat management, as we'll see. Don't worry though. Now the scary part, the ST-Link. The Eddy sensor needs a newer protocol than the stock SV08 supports, so we have to manually update both the toolhead and the main board. Good news, Sovol includes the programmer tool. These are genuinely useful to have and cost just a few bucks on AliExpress, but now we don't have to wait for delivery. The bad news? You need a Windows PC for these steps. Macs won't cut it. A friend with a PC will also do. Both the ST-Link software and the firmware come on the USB drive in the package. Wiring is the trickiest part. There are a lot more pins than wires. On the ST-Link, connect yellow, red, black, orange to the bottom row of pins, the empty pin next to the orange wire. On the toolhead port, the order is orange, red, yellow, black. Pay close attention here. One row move lets the magic smoke out. Plug the USB into your PC, click Settings, refresh, OK. Then connect and program. If you see verification OK, you're golden. The booklet includes troubleshooting if you need it. Fortunately, we didn't. Halfway done. Now for the main board under the printer. We need to update the other end of the umbilical cable too. Yes, we have to flip the printer and remove that bottom cover. No escaping that, but you know what? I'm extremely happy with this new Hotto Pixel screwdriver. It's not only cool, Levi unboxed it in the live stream. The torque setting is essential in precision work like this, and who would have thought I'd actually enjoy removing all these screws holding the bottom cover. Find links to this and other Hotto tools in the description, and be sure to use our code gerGO for a substantial 15% discount site-wide on hottotools.com. Inside the SV08, we find the programming port. It looks identical to the one on the toolhead. Keep the ST-Link side connected, but plug the other end here. The orange wire goes to the pin closest to the power supply. The flashing process is identical to the toolhead. Surprisingly, we even write the exact same firmware file we used for the toolhead. Done in 2 minutes. Before powering on the machine, we still need to connect the probe to the BL touch socket, and stealing an extra 3.3 volts from the leftmost pin of that programming port we are so familiar with by now. Don't forget to plug the front fan into the port labeled fan 4, and since my toolhead is an early variant lacking the top pin, I'm still using that printed security clamp I showed you in my 5 tiny upgrades video. Next, prepare the USB stick. You can use the included drive, but make sure to back up the files and quick format it using FAT32 with 4K allocation units. I missed this detail and my first upgrade attempt failed until I did this. copy the DB file from the firmware folder to the root of this USB drive. Now turn the printer on. It will hang on the system booting screen. No worries though. Just plug in the drive and wait 2-3 minutes until you see it auto reboot. If nothing happens after 5 minutes, try a different thumb drive. Your config files are now overwritten, so refer to this earlier video of us on selective restore to merge your old settings back. I had to re-add the include line for my macro collection and readjust sensorless homing sensitivity to avoid that big bump. Finally, you'll want to redo your calibrations, specifically adding a new one called Get LDC Current, found under the Advanced menu on the mini screen. This only needs to be done once or when you change anything with your bed or tool head. So we followed the instructions, we calibrated, we printed a test whistle, much more useful than a test cube or benchy. All worked. Are we done? Hell no. The new adventure has just begun, because on a hunch, I decided to print another whistle, back to back with the last one. Bed still hot, nozzle just cooling down. We ran the same G code. Just like the first time, it went to clean itself. And that's when the horror started. You can hear me wince in the footage. Yet for science, I forced myself to watch it happen a few more times just to fully understand. The tool head homes, moves to the front, which is unnecessary, and the mini screen flashes clean nozzle, then immediately nozzle heating. The probe tries to find the bed, but instead of stopping, it digs itself deep into the PEI sheet. The Z motors grind horribly, skipping steps. Look at the console. It's even worse. Since the sample count is set to 3, it repeats this 2 more times. After the initial fail, it digs deeper and deeper into the build plate, each time showing a no trigger on probe error before finally giving up and aborting the print. Now we have an ugly hole on our build plate, and I don't want to know how the hot end bent out of shape. But why? What happened? Well, I looked at the new macro CFG code and realized the issue eventually. The Sovol Eddy implementation doesn't have active temperature compensation. When the nozzle is cold, it works. But when the nozzle is hot, like 200 degrees Celsius from a previous print, the heat radiates into the probe coils, the sensor goes blind, it thinks the bed is further away than it actually is, so it keeps pushing the nozzle down and down and down right through our build plate. But not yours, because we make mistakes, so you don't have to. The fix is actually pretty simple. There is one line you'll want to add to your macro CFG, and thanks to the fully open source nature of Sovol printers, we can even add safeguards in the internal Python code, but that's optional. So first, prevention. We modify the clean nozzle macro. Originally, it heated the nozzle to 200 C before probing. Bad idea. We should change that to heat only to 150 C initially. That's hot enough to squish any ooze on the tip, so the measurement is accurate enough. This is just the rough pre-cleaning Z height check, so we don't need that much accuracy yet. But 150 C is cool enough that it won't blind the sensor. We only let it heat to 200 C after the probing is done. In fact, if it was over 150 C to start with, it will now wait for the nozzle to cool first. This one change prevents the drifting and crashing. But there is a second component, as I said, the safety net. By default, even if the probe fails, Klipper keeps probing 3 times. Normally, you do need 3 samples for accuracy, but in case of an error, this will lead to 3 crashes in a row. Time to modify the Python script, probe Eddy current.py. I'd recommend using WinSCP to log into your printer. User and pass are both Sovol. Be sure to right-click on the file and make a duplicate of it for backup. Now you could double-click to edit, find the section Run Probe Where Contact, and manually wrap the probe command in a try except block. But better yet, I have included the fully modified file in our SV08 improvement project on Calc3D. You can just drag and drop it to override the original. One important warning here, since you are modifying an internal Klipper file, a future system update will likely override this file and remove our safety net. So if you update Klipper down the road, remember to check if this fix is still there. But for now, if the sensor fails to trigger even once, the print will abort immediately. No grinding, no holes in the bed, just a safe error message. Now that it's safe, let's make it perfect. This is my new start print G-code in Orca, taking out the unnecessary movements, still starting by preheating the nozzle even before homing to shave off a few seconds in the preparations, but only to 130 C, then to 150, then only after probing to 200 C for cleaning, and finally to the print temperature for your filament. Multi-stage heat up. I also noticed it was doing a conditional QGL, quad gantry leveling, only before mashing. You can keep it conditional there, it won't run anymore, since I added an unconditional call to the QGL earlier in the process. It's just better practice even after a previous print. Bed scanning is now safe and quick, but can we expect accuracy at this speed? We absolutely can, but printing our usual 9+4 circle first layer test, I noticed it was far from perfect. Kind of okay on the right, but way too high everywhere else. A bit of research told me this most probably is axis twist. Our metal gantry is slightly twisted. Yours might be too. Klipper has a fix though. We just need to enable axis twist compensation in the config. This gives us the command axis twist compensation calibrate, which will assist in probing 3 points with the classic paper method to teach the printer the shape of the twist. If you don't have the Klipper screen, it has a UI in the web interface as well. Once enabled, the first layer became dead flat across the entire bed, but now it's too high everywhere. The Eddy sensor is precise, but it tends to calculate the Z offset a tiny bit too high for my taste. We surely don't want to baby step before every single print, so I ended up adding a set G-code offset Z adjust command to the start print macro right after probing. There might be other ways to get around this, but we just automatically nudge the nozzle down by 0.07 millimeters every time, giving us that perfect swish without lifting a finger. You'll see its effect in a minute, but now one final bonus tip I promised. The stock cleaning macro dives the nozzle to Z equals minus 1.5 millimeters to reach the brush behind the build plate. And this is terrifying. If your homing is off by even a few millimeters, you are not only ramming the nozzle into the bed, but it is also going to scratch it back and forth. Say goodbye to your hot end, PEI, and possibly the whole tool head. A tiny calibration error in the sensorless homing, the print head gets stuck halfway to the home back corner, and it will blindly start cleaning in the middle of your build plate. A small problem turned into a real catastrophe because the current setup makes it necessary for the nozzle to be lowered below the build surface to do so. Into the build surface if we are not off of it. The fix is straightforward, something we did to our SV08 Max 2 after a bad homing scratched up its PEI sheet. We just need to raise that cleaning pad by 2 millimeters. So the whole cleaning process can happen above water. In case of a homing error, the worst that can happen is the nozzle is shaken a few times in the air. No destruction. I designed this simple 3D printed riser, exactly 2 millimeters thick, that sits under the cleaning block. The original M3x12 screws are long enough to sandwich it between the block and the printer. This raises the brush and scrubber up, but very important next step is to then update the macro to clean at 0.5 millimeters. Just change this line in the clean nozzle macro. I found moving the head just 0.1 millimeter higher later keeps scraping effective but less stressful. And while at it, we can also extend the scraping path a bit. It was just a few millimeters before. You can copy all my changes off my screen, but for your convenience, I've included the updated start print and nozzle clean macros in my macro collection, overwriting the stock ones, along with the STL for the 2 millimeter spacer in the SV08 improvement project on CALS 3D. So you don't even need to change anything in your Orca Slicer presets, but remember to re-include my macros after any firmware updates. I promise the final test. The printer starts, probes at a safe 150 Celsius, then cleans high above the build surface level. Levels the gantry, QGL. This I sped up because it hasn't changed, but notice it runs before the critical measurements. Now the easy offset calibration. I'm leaving this in real time so you can see exactly how it behaves. It takes about 36 seconds, taking multiple samples at various plunge speeds to ensure accuracy. While we wait for this, do I actually recommend this Eddy kit after all the trouble? Stick around, I'll give you my final verdict in just a minute. But if deep dives like this are valuable for you, please take a moment to hit that like button and subscribe for more videos like this. Thank you if you did. Next up, scanning the bed mesh. I'm letting you watch this in real time too. It's technically doing an adaptive scan, but since our first layer test covers the whole bed, you get to see the full speed across the entire surface. It is making a 41 by 41 mesh, 1681 points in total, 1 row per second. Just incredible. If you decide to purchase this upgrade kit or any other accessories or 3D printers from Sovol's website, please use our affiliate links in the description. It helps us a ton without costing you a penny extra. After the standard purge in the front, it lays down a perfect first layer. I'll give you a little close-up here of each circle as they go down one by one. And while we watch these perfect lines appear, let me give a massive shout out to our most generous supporters on Ko-fi.com. Your sustaining contributions make projects like this possible. But we are just as grateful for every single coffee or hot chocolate for Levi. It really means a lot. Look at this, all circles turned out amazing. The Eddy probe upgrade is definitely worth it for the speed and cool factor. Don't be scared of it, but only if you apply these fixes. Out of the box, it's a bit of a gamble with your hardware. This Sovol kit is the easiest handheld option in my opinion, keeping your original toolhead without adding extra cables. If this video saved your build plate or was just interesting, hit that like button and maybe subscribe to see what Levi and I break and fix next time. check out our full SV08 journey in this playlist. And be sure to watch our very first live stream celebrating 10K subs here. Now go print 3D. Thank you for watching another gerGO Print 3D video all the way to its end. Stay safe.